Good afternoon all. Am I audible?
Good afternoon, sir.
Yes, sir, audible, sir.
Any doubts are in the discussions of last class? We finished the.
No, sir.
Is it clear?
Yes, sir. Clear.
Usually, we can find electric field at a point using Gauss law also. Okay.
Yes, sir.
So here to find in the vicinity of a charge configuration using Gauss law. See, here we have to consider some closed surface in surrounding the such that the point where we need to find the electric field Understood this?
Yes, sir. Understood.
Yes.
Understood this? I'll explain one by one.
Yes.
Shall I turn this?
1 month.
Completed, sir.
Sir, 1 month, sir. 1 month. Yes, sir. Completed.
Finished?
Yes.
See, suppose you're having a point charge here. I want to know here at a distance of r the electric field. For that I need a Gaussian surface. Now suppose I take some arbitrary Gaussian surface. For example, if I take some surface like this, you can see that this distance and this distance are not same, no? Are the distances same?
No,
No,
sir.
sir.
Yes, sir.
That means E will be different, no? At these
Yes, sir.
points,
Yes, sir.
E will be different, no? At this point, all these points, E1 will differ. That means I can say that if you take this as O, 2, 1 like that, magnitude wise E is not same, no? That is guaranteed.
Sir.
Why? Since R is same, R is different. Okay. Or I mean another problem you have is you can see that will theta be same?
No, sir.
No, sir.
If I keep a plus 1 charge here, it goes like this, no? This is E1. Whereas for this point is n cap, no? This is one theta 1. Again, this is like this is another theta 2, no? Again, this is E bar, this is N2, no?
Yes, sir.
Agreed. So you can see that theta angle between So now Gauss law you have to find E1 ds1 cos theta 1 because we need this now. Is not possible to evaluate now. You
Yes,
can
sir.
choose any surface. Problem is if you choose such a surface, it will be a headache. On the other hand, I will use such that R should be same means what will happen? E will be same no? That
Yes,
means
sir.
at a distance of R at any point, if it goes surrounding, what will get here?
Here.
So if I choose a Gaussian surface, then what will happen? Angle between what? Do you agree till here?
Yes,
Followed this
sir.
or not?
Followed, sir.
Also magnitude is same no?
Yes, sir.
Till here you followed.
Followed, sir.
Shall I turn the page?
Minute, sir.
1 minute, sir.
Completed?
1 minute, sir. 1 minute.
You can choose this surface also, but you cannot integrate no? Agreed. A blade also cuts, an axe also will cut. To cut a paper, you don't use axe, no? Or you cut a tree, you cannot use a blade. Not that you should not, but you won't because output will not be there. Here also you can choose any surface, but you cannot determine this value.
Agreed, sir.
Shall I turn this?
1 minute, sir. Last thing.
Done, sir.
Minute, sir.
See, I posted tomorrow's syllabus, you can see in the group. Shall I turn this? Now see, by choosing the proper Gaussian surface, If I choose a sphere, we need here only the distance of r. Now you can see for any surface you have ds cap. This is E. So we'll apply now as E is constant, I can remove from the integral now.
Yes, sir.
Sir.
E is constant. Till here you followed?
Yes, sir.
What is the sum of all these things? This is nothing but
Yes, sir.
okay, this is nothing but E 4 pi r square. No? Now from Gauss law, total charge enclosed by epsilon naught. So E is you have the same thing previously, no? What is the electric field here? Understood this? You got the
Yes,
same thing
sir.
or not previously?
Yes, sir.
Same thing, sir. For sphere, same thing.
Is it clear?
Cleared.
Yes, clear.
Understood this?
Understood, sir.
1 minute, sir, writing.
Shall I turn this?
Yes, sir.
1 minute, sir.
Completed?
Yes, sir, done, sir.
Yes, sir.
Now the surface on for which we apply Gauss law is called as Gaussian surface. chosen to apply Gauss law. Understood this? Is it clear?
Yes, sir.
Now, using Gauss law, let us see. So here, so there's a charge here, totally non-conducting. No? As an example, you can take nucleus. All protons in the same place they have no assembled. Agreed? So this has some radius. Now I want to know the electric field at some point here. What we will do, as you know, we will take a Gaussian surface with a sphere. So I have chosen a Gaussian surface. Its center understood this? Clear or
Yes,
not?
sir.
Now
Clear.
you take at any point, how does the electric field be? Radial only, no?
Sir, radial.
Agreed.
Yes, sir.
Therefore, what is theta? Followed. Then I'll apply E ds cos 0 for the whole surface. What is the charge enclosed? This is E is constant. ds q by epsilon naught, no? This is nothing but 4 pi r square, no? So you get E or not?
Yes, sir.
Same thing you got previously, no?
Yes, sir. Same thing.
Is it clear?
Yes, sir.
Shall I turn this?
One minute, sir.
Tell.
Sir, I asked for time, sir, for writing.
Understood this?
Understood, sir.
Shall I turn this?
1 minute,
Yes.
sir. Completed, sir.
Suppose we want at some point here. What you'll do? You'll choose a Gaussian surface of this. Okay.
Yes.
What we'll do? Understood this?
Yes, sir.
So here also you can see how does the electric field be at any point? The electric field now.
Yes, sir. Outside.
So what is the charge enclosed by the sphere? What is the volume of this? Okay, what is the rho? Total charge distributed by this, no? Do you agree with this?
Agree, sir.
Till here, any doubts are there? Then I'll apply Gauss law for this. You can see again you have E ds cos 0 only, no?
Yes, sir.
E is constant at every point, I can remove, no? E into what is this? Surface area of Gaussian surface, no?
Yes, sir.
Follow this? Why?
Followed, sir.
Because ds, sum of this means ds is part of Gaussian surface, no?
Sir,
Yes.
some
Yes, sir.
That will be the total area.
So this okay.
Yes, sir.
What is there in that substitute, no? Q by epsilon naught.
yes, sir.
You got the previously same thing, no? See? Same thing you got or not?
Sir, same thing. Remember, sir.
So if you choose proper Gaussian surface, you can find the electric field easily. Shall I turn this?
1 minute, sir.
Shall I turn this?
1 minute, sir.
Completed, sir.
Last line, sir. 1 minute. 1 minute.
Any doubt is there till here?
No, sir.
Shall I turn this?
Yes, sir. Complete.
So From here to here, the electric field is linearly changing. No?
Yes, sir.
It reaches the E surface one. After that, it drops like this. E surface followed this.
Followed, sir.
Sanitize. Hmm? మరి ఎక్కడికి వెళ్తాం? That means at any region you have electric field. It is always radially outward, no?
Yes, sir. For sphere.
Its charge is positive. Understood this?
Understood.
Shall I turn this?
1 minute, sir.
Shall I turn this?
Yes, sir. Completed.
For a solid sphere, if you give charge, where does it reside?
Surface.
Outer surface.
Hmm?
Outer
Sir.
surface.
Outer surface, sir.
Periphery.
On outer surface, huh?
Yes.
That
Yes, sir.
means there will not be any charge inside. Now suppose we need inside, you will take a Gaussian surface. Okay. Understood this? What is the charge enclosed? Zero, no?
0, sir.
Understood this? That is the reason why inside you don't have an electric field.
Understood.
Followed this?
Followed.
For this Gaussian surface, we can apply the same way now. What is the charge enclosed?
Q.
Entire charge on the sphere is enclosed, no?
Yes, sir.
Do you agree with this?
Agree, sir.
Any doubt?
No, sir.
Usually for spherical charge distribution, we choose the spherical Gaussian surface.
Sir, apart from spherical, are there any other Gaussian surfaces?
You can take anything I was telling you from beginning.
Yes,
If
sir.
you get capable of finding E1, D1 cos theta 1, E2, ds cos theta 2, you take any shape. Because I cannot find out, I am taking a sphere. So that E ds cos 0 will be there. You are having every right to choose any surface. Problem is that summation is very difficult. So for spherical charge distributions, if you take a spherical Gaussian surface, evaluation of E dot ds will be easier. Understood this?
Agreed, sir.
Sir.
Shall we turn this?
Yes. Done, sir.
One minute, sir.
Finished?
Yes, sir, done.
Yes, sir. Done, sir.
Yes, sir.
It's a conducting sphere. Okay.
Yes, sir.
Agreed?
Agreed.
R equals R if you take what is there. Understood this? Is it
Understood.
clear?
Yes.
This is for understood this?
Yes, sir.
So if you take any charged sphere, this is still here, no electric field, distance from the center.
Yes, sir.
Followed?
Good, sir.
Previously also, this is the distance from the center. Understood this?
Understood.
Then afterwards, suddenly it rises. This is the graph. Understood this?
Understood, sir.
Shall I turn this?
1 minute. Completed, sir.
Finished?
Yes, sir. Yes, sir.
The long wire. Understood this? See, this charge density Linear charge density. Follow what I am saying?
Followed.
That means this is infinity, it goes to infinity. Any doubt is there?
No, sir.
Suppose I need at this point. Now tell me which surface I should choose so that electric field will be always parallel to it. See,
Cylinder, sir.
definitely sphere, by using your mind you can see you'll have a visualization. No? If you take a cylinder,
Yes, sir.
suppose this P is at a distance of R, then you can see at any point on the curved surface, this is E, this is N cap. On the plane surface, see E will be grazing like this now. This is E now. Whereas N cap for the plane surface is this now. Similarly, this electric field now.
Sir.
This will be N cap now.
Yes.
Yes.
Do you agree with this?
Yes.
Cylindrical Gaussian surface such that the wire understood this.
Understood, sir.
Now there are three surfaces now. Do you agree with
Just
this?
question 90. Yes, sir.
Agreed, sir.
So here you have so when you're applying for this, you have to apply for all three surfaces, no?
Yes, sir.
Entire Gaussian surface you should apply. Do you agree with this? For
Agreed.
one, what you have? So this is zero, no? Till here, followed?
Follow, sir.
Shall I
Followed.
turn this?
1 minute, sir, please. 1 minute.
Suppose this length of the cylinder is L, and the length of the wire is also L only, no? Shall I turn this?
One minute, sir. One minute, sir. Okay.
Done, sir.
Complete.
See, any point on the curved surface is same distance, no? From the
Yes, sir.
wire.
Yes, sir.
We can write. Do you agree till here?
Agreed.
Hmm?
Agreed, sir.
Do you agree with this? Therefore, previously what you got here, you got this now?
Yes, sir.
Complete this. You noted down this one.
Yes, sir. Noted down.
Surface 1, surface 2. This means this integral applied to surface 1. This means integral applied to surface 2. So here for surface 1. Okay. Next. E is same. I can take it outside now.
Yes, sir.
Do you agree?
Yes, sir.
Do you agree with this? This is nothing but understood this?
Understood.
Previously you got the same thing or not? See? Long wire what you have? You have only this component, remember? This is
Yes,
0.
sir.
Sir.
Yes, sir.
Previously we derived this. Same thing you got now or not? See?
Same thing.
Yes, sir.
Is it clear?
Clear, sir.
Clear, sir.
Shall I turn this?
Yes, sir.
1 minute, sir. 1 minute, sir. Please. One.
You're able to follow the essence of this, what I'm saying?
Sir, you are
Yes,
able
sir.
to follow.
Finished?
Yes, sir. Yes, sir. Completed, sir.
Shall I turn?
Yes, sir.
Now suppose he may give anything, you should use the charge configuration. This is cylinder. Okay. Now this is the axis. This is R. I want to find the cylinder electric field at some point inside. So this charge distribution is rho. So the length is L. Followed this?
Yes, sir.
How to find this? Now I'll choose a cylinder like this. I can choose this now.
Yes, sir. It is enclosing the.
This is L.
Yes, sir.
Okay, now this is the Gaussian surface. For this Gaussian surface, we are having the curved surface as before. At any point you have this as 0.
Yes, sir.
Upper plane surface. I am writing here means this integral is for that surface. Because the surface integral now.
Yes, sir. Lower plane surface.
Together charge enclosed by epsilon naught. Do you agree with this? Now
Yes,
for
sir.
the curved surface, you can remove this because E is same at every point. No?
Yes, sir.
For other two, it is 0. No? Now
Yes,
what is
sir.
the
Yes, sir.
volume of this? Do you agree with this?
Yes.
This is curved surface area. No?
Yes, sir.
Understood this?
Understood.
Understood, isn't it?
Yes, sir.
Any doubt?
Sir.
Shall I turn this?
1 minute, sir.
1 minute.
Completed, sir.
Yes, sir. Completed.
Finished?
Yes, sir.
Shall I turn this?
Yes.
Just a second.
Now you find out at this point, this is the axis, no? This radius is r. I want to know the electric field. What I should do? Choose
Another Gaussian surface.
same cylinder. Your wish, you can choose any length because anyhow that is getting cancelled, no?
Yes.
Again you have, this is surface 1. Follow this.
Yes, sir.
For surface 1, surface to what is the charge enclosed here? First one is E dot ds. What is the charge enclosed? Volume of this, no? See,
Yes, sir.
charge is not enclosed by this. Charge is only within this. You're able to visualize on it. Charge is only within this region.
Yes, sir.
We can calculate, correct, no, sir?
Charge enclosed is how much? Pi r square into L into,
Oh,
Rho.
do you agree or not?
yes, sir.
Agree, sir.
Yes, sir.
Okay. No, pi r
Yes.
square. R is this. Please be careful about this. This is R now.
Yes, sir.
You don't have charge throughout. Only till here you have. Understood
Yes, sir.
this?
Understood, sir.
So this is E same at every point. This is nothing but
2 pi 12.
understood this.
Yes, sir.
Shall I turn this?
1 minute, sir, please.
1 minute.
What is today's date, man? 11th, huh?
12th, sir.
12, sir.
See, tomorrow you'll have a class in the evening, man.
Okay, sir.
Okay,
Okay,
sir.
sir.
We couldn't complete the required because I told no there's a timetable for us.
Yes, sir.
If I don't go according to that plan, again by October I cannot complete.
Tomorrow at what time, sir?
After exam, because before exam I have to study, no?
Okay, sir.
Evening we'll keep.
Yes, sir.
Second day it syllabus is yours, so you'll be having very hectic schedule. I told last year on, no? First year will be little bit lenient. Second year and everything will be observed. And in the end you'll be knowing the drama of MS College. Gauss sir will enter, then he'll show what he is MS College. Some people are happily coming, going, no? Don't think Gauss sir once he enters, they're giving free of cost, man. Gauss sir is of the opinion we are collecting so much fee from other batches. No result, no attendance. What is this? Because we will simply say they are not attending regularly. What is that? So be careful and be regular. And some people are leaving as if attendance. That is also observed. Ajit sir is also doing all this to one report will go to Gauss sir. He won't ask. He'll suddenly come on. He'll bombard the parents left and right. I think he did not face Gauss sir so far. That's why still you are not knowing what he is. First year, okay, second year, you'll have a lot of hectic work. And we will also be under pressure.
Sir,
Syllabus,
we were
all.
having 3 hours classes. No, sir. Why 2 hours now?
Yeah, the evening you have math Sharma sir class, no?
Sir, after 11 we don't
After
have any
morning,
class.
yes, sir.
The problem is, no, juniors have come in now, that's the problem. Your juniors have, now we have 3 batches, man, outgoing, incoming senior, incoming juniors. I told now, once juniors come, we cannot run the show. Evening only it's possible, daytime I have packed, evening Sharma sir is there. Sharma sir is having some class, 8 o'clock or something, 7 o'clock or something is there.
8 to 9.
To 9.
Shall I turn this? Understood this?
Sir.
Sir, understood.
Completion of syllabus is easy only if you cut short everything. Now suppose it's a conducting. Conducting cylinder, where will the charge reside? See, there is
Surface.
no material here. Okay. Hollow. This is also open. Now, charge given resides where?
Surface.
Follow this.
Yes.
Now, suppose I need at a distance of, say, smaller. As this is the radius, this is smaller. I want here. I'll take a cylinder, same story. Then what you have for the Gaussian surface? Curved one.
Upper surface.
Following?
Following, sir.
Charge enclosure is how much? No charge is there inside, no?
Yes, sir.
Understood this? Second year, don't keep any programs for this year, like function on Sunday, I'll go to all that over. Even now, outgoing seniors are struggling. Very few people are now on hold. Many people start enjoying. Hardly 7, 8 people are writing the exam. Slowly like that, because the exam is far. We need lot of temperament to be patience. You should be there to be successful. You know, every scientist saw thousands of times failure. So every failure has given them an opportunity to rethink. That means every failure teaches a lesson. You failed 1,000 times means 1,000 lessons you had. That means you became more stronger. Sunday is coming, I'll enjoy. All that you should believe. Even we are also working, no? Round the clock. Shall I turn this?
1 minute, sir. 1 minute. Done, sir.
So the same thing, this is open. Okay. Now at a distance of r we need, what we should do? Choose again a Gaussian surface. Again this has upper surface. Again apply at any point for the surface 3. At any point for surface 1 and 2. Is charge enclosed. This is EDS. What is the charge enclosed means? Suppose this is L. You will get surface charge density into the length, no? Surface area is that only, no? Understood?
Yes.
Any doubt is there? This is E is constant as before, you know. What is the surface area? Charge enclosed is still here only, no? Only this part, man.
Yes, sir. I did.
Now you are telling us, sir. Before,
No, sir. Let's do it.
is it clear till here?
Yes, sir.
Any doubt?
No doubts. Yes.
Now you have an idea of how to apply Gauss law.
Yes, sir.
Yes, sir.
Shall I turn this?
Sir, 1 minute, sir, please. 1 minute.
Done, sir.
Yes, sir. Done, sir.
See, there is a sheet of charge. You know what is a sheet of charge, you know?
Yes, sir.
Followed this. Is it clear? Now see,
Yes.
if I look like this side view, you know,
Yes, sir.
it will be like this only, no?
Yes, sir.
Yes, sir.
Now I'll take a Gaussian surface such that it pierces this. That means this is exactly passing through. This means this is enclosed by this. Till here you followed. Now you can see that due to the sheet, electric field will be like this only, no?
Yes, sir.
Do you agree with this? And again, for the curved surface, this is this. N cap is this, no? Do you agree with this or not?
Agreed, sir.
Yes.
Hello, sir.
Tell me.
Sir, n cap for that curved surface will be.
Perpendicular, no? For
Sir.
curved surface, N cap is what? Perpendicular. Radial
Yes, sir.
directional, no?
Yes, sir. Yes,
Yes,
sir.
sir.
So
Understood,
far
sir.
you have done all the problems on this only, no?
Yes, sir.
Sir,
Yes, sir.
for
I got
left side, A
confused.
bar will be in this direction, no?
Which one?
Yes, sir. For one surface,
Hmm.
A bar direction.
No man, this is the electric field sheet, no? This will be E bar like this. Backside also E bar will be like this, no?
Yes, sir.
Yes.
Forgot this?
No, sir. Remember.
Electric field is a sheet of charge. Already that other day
Yes,
we
sir.
have
Yes,
done
sir.
this.
Yes, sir. Yes.
Understood this?
Yes, sir.
Yes, sir.
Let radius of cylinder be R. Understood this?
Yes.
Then for the curved surfaces, EDS cos 0 for 1, EDS cos 90 for 2, EDS cos how much?
80.
0 for surface 3. Any doubt is there?
No.
Agreed. Charge enclosed. See, this is the charge, no? Sheet into what is the area enclosed? Pi r square, no? Any doubt is there till here? This is the area, no?
Yes, sir.
That is nothing but pi r square only, no? Any doubt is there till here?
No doubt, sir.
Shall I proceed?
1 minute, sir.
Shall I turn this?
1 minute, sir.
1 minute, sir. Done, sir.
Shall I turn this? Now you can see for this, this is anyhow 0. All of you following this?
Yes, sir. Following.
This is E into, what is this you have? Understood this? Understood this? You got the same
Yes,
thing,
sir.
remember?
Same thing.
Yes, sir.
Yes, sir.
See, man, what great brains Gauss has. We are feeling difficult to understand what is already invented by them. Finished?
1 minute, sir. 1 minute. Done, sir. One minute, sir. 1 minute.
You understood fully?
Yes, sir. Understood. Completed, sir.
Now, in case of a conducting sheet, what will happen?
So charge will reside on all this.
Hmm. Understood this? That means here with the sheet is there. Now side view, you have this. Again you choose a cylinder. Now you can see this is the region wherein you have, there are really two regions, no? Agreed. So charge enclosed is how much?
Sir, then what is the difference with the last case, sir?
Pardon?
In that, in last case also, sir, means this surface only, no, sir. One sheet
Yes,
means
man. Wait, man. When you give charge to a conducting one, that distributes on both pages, front and back. But
yes,
if you give a non-conducting sheet, if you take, you give charge on this, that won't be going to the back side. Understood this? That means I can view this. If you take this as thickness of the sheet, for example,
yes,
I'll show. This is on thickness, for example. This is a page, something, T. When you give charge to this, suppose you give charge on this, it will be here only, this side only charge, the other side no charge. Suppose you're following this or not?
yes, sir, following, sir.
Suppose this is conducting, then it will be distributing this side and that side. That is the difference.
Yes, sir, yes,
Understood this? On the other side, if you take the same thing, that means charge will be only on one side, wherever you give. Understood this?
yes, sir,
Now, if you take a
Yes,
conducting sheet, the difference is the same charge distributes both front and back. Automatically, it will go anywhere you give. This is conducting, this is,
non-conducting. Yes,
that is the difference. Understood this?
yes, sir, understood, sir.
Any doubt is there?
No doubt, sir. Clear,
Hmm?
clear, sir, clear.
So, you know that this is electric field, this is N cap, this is the electric field, this is N cap, this is the electric field, this is N cap. Okay?
Yes, sir.
Now, I'll apply E dot ds to everything. Can I write like this?
Yes, sir.
Charge enclosed by epsilon naught. This is E 0. What is the charge enclosed front and back now? You're able to visualize. So this needs lot of visualization. What is the surface of this? Do you agree with this?
Agree, sir.
agreed, sir.
This is
Yes, sir.
get E. You got the previous thing, same thing, no? See,
Yes, sir. Now it's making sense.
this is different.
No, sir, no, sir. It's making sense now.
No, no, it makes sense now. Sensible things only I'll teach. I'll never teach nonsense. All of you followed this?
Yes.
Followed, sir.
You understood the difference between first year and second year?
Understood.
There, understanding the concept is very easy, applying is difficult. Here, understanding the concept is difficult.
Playing is also difficult, sir.
So, non-conducting sheet charge means charge will be only on one surface to where you are given, that is front side or back side. Conducting sheet of charge means in any side you give, there will be charge going to the other side also. Understood the difference between these two?
Yes, sir.
Yes, understood.
Understood, sir.
Good. Shall I turn this?
Yes, sir. Completed.
1 minute, sir, 1 minute.
Finished?
Yes, sir.
So remember that any sheet of charge, see, suppose like you use a blotting paper, then if you write on one side, it will go to other side also, no?
Yes, sir.
Do you agree with this?
Yes, sir.
Understood this? Now is it clear?
Yes, sir.
Understood this? Is it clear now at least?
Sir. Clear, sir.
Followed?
Yes, sir.
Clear, sir. Followed, sir.
Follow this. So here is back surface, no charge. This is case of what? This is thickness. T is negligible. Understood this?
Yes, sir.
Yes, sir.
This is for conducting.
Non-conducting.
Same way. Non-conducting also same story. Only thing is non-conducting, sorry.
Yes, sir.
Yes,
That
sir.
one.
So conducting means any charge you give that goes on both sides. Like blotting paper. You know that, no? This is
Yes,
charge.
sir.
This is also charge. This is conducting sheet. Is it clear?
Yes.
Yes, sir.
Yes, sir.
Right, go through this. Okay, I posted the syllabus also. And write the exam properly. Okay, take care. Bye.
Thank you, sir.
Thank you, sir.
Yes, sir. Thank
Bye,
you,
sir.
sir. Bye.
Bye bye. Go to the teaching module.
Yes, sir.
Yes, sir.
Yes, sir.
Thank you, sir. Bye, sir.
Bye bye bye.